Okay, so for synthetic and polynomial division, you will have to do these by hand, not just punch it in the program. If I have a problem that looks like this, I want to divide x cubed minus 2x squared minus 9 by x minus 3. Okay? This actually ends up being almost the same type of problem as if I asked you to divide 730 by 3. Okay? You set it up the same way. You're going to use the same symbols. You have x minus 3 out front, though, because your divisor, instead of being 3, is x minus 3. Your dividend is what's underneath, x cubed minus 2x squared. Now, one thing I want you to notice, this 730 represents having 7 100s, 3 10s, and 0 1s, right? Going way back here. This represents you have 1 cubic term, negative 2 of the square of the quadratic term, and negative 9 constant. What are you skipping? The x, the linear term. You need to account for that. I have 0 1s up here. I couldn't write 730 without the 0 there. When I'm doing the division, I need to have plus 0x. Otherwise, it will screw up on you. Okay? Sometimes if you're comfortable with it, you can compensate for it not being there, but it's easier just to put it in. And then you have the constant after that. Okay? Now, when I'm doing this problem, what do I do first? Yep. How many 3's going to 7? 2. Now, it doesn't go in perfectly, just like down here. I have x minus 3. Well, I looked at the first term here. I'm going to look at the first term here. X goes into x cubed how many times? Now, careful. What you're really doing here is 3 times 2 gives you a number close, right? So think about it in the same terms. X times what gives you x cubed?
X squared.
X squared. So I'm going to put that above the squared. X times x squared gives you x cubed. So when I multiply it, 3 times 2, I get 6. And then I do what? Subtract. I'm going to do the same thing down here. X times x squared is x cubed. And then I'm going to subtract. Thing is, I don't just have x out here. What else do I have? Minus 3. So I also have to take negative 3 times x squared. That gives me negative 3x squared. So I usually put parentheses around this just so I have a mental or a visual thing to remind me that I'm going to subtract everything there. When I subtract these, the x cubes cancel. That's why we chose them. Negative 2x squared minus negative 3x squared gives me just 1x squared. Here I do the same thing. 7 minus 6 gives you 1. What do I do next up here?
Bring down 3.
Bring down the 3. So what do I do next here?
Bring down the 0.
Bring down the linear term, yep. Now, I'm no longer looking at the 730 up here. I'm now looking at the 13. 3 times what comes close to 13? 4. I'm going to do the same process down here. X minus 3, the x times what comes close to x squared? Just plus x. When I multiply that, that's going to give me x squared minus 3x. Yep. Then what? Subtract. Positive 3x. 0 minus negative 3 gives you positive 3. The most common screw up on this stuff is going to be messing up a negative sign somewhere in this body of work. Okay? Bring down the negative 9. Then what?
3.
Where?
3.
Yeah, up the top. X times 3 gives you 3x. Negative 3 times 3 gives you negative 9. So when I subtract these, 0. That 0 represents what?
No remainder.
Yeah, the remainder of 0. So the idea is if I want to use this process to factor the polynomial, okay, that means I know x minus 3 goes in evenly because I got 0 for the remainder. That times your quotient will give you back what you started with. So the idea is this is a factored form. Now, does it break down any further is the question. Well, x squared plus x plus 3, will that factor further? No. Nothing you multiply to get 3 is going to add up to be 1. So this is your factored form of that polynomial. It's not pretty, but it works. Questions? Yeah?
What do you do if there is a remainder?
We'll deal with that in a minute. Your turn.
No.
Go ahead and take a couple minutes and divide these two. Okay, so I'm going to take everything out front times that x cubed. That's going to give me x to the fourth plus 1x cubed. Now when I subtract it, here's where people usually go off the rails. Make sure you actually subtract this. 0 minus 1x cubed is negative 1x cubed. Okay? Now I only bring down the next term. I don't bother bringing everything down with it. So that's plus 0x squared. Now, what's going to go up here? Negative x squared. Because what I'm looking at is, what do I multiply x by to get the first term in this line? X times negative x squared is negative x cubed. So negative x cubed. Then I actually write down what I get when I multiply both of these things times that. Negative x cubed and then minus 1 times that x squared. Now I'm going to subtract everything in this row again. What do I get in the next line? Positive x squared. Bring down the 0x. Rinse and repeat. X times what is x squared? Multiply it through. Then do your subtraction. Gives me negative x here. Bring down the negative 1. What do I multiply by? Negative 1. Gives me negative x minus 1, which gives me a remainder of 0. Okay. You got to keep track of all the moving parts. Okay. Now, because of this, the fact that you have the divisor here times the quotient, if you tack on the remainder, whatever it is to that, that'll always give you that dividend. Okay? The book talks about this a little bit with the symbols, but it means the same thing. Now, as far as writing a solution, though, you need to have, if you don't have this remainder written down, if you're actually dividing the dividend by the divisor, well, then I would divide everything by d of x, including the remainder. That's how you end up having to write the solutions when you have a remainder. If they're asking you to divide two things, if they're asking for the factored form, well, then you'd have no remainder. It's 0. But if they're asking you to divide it, you might have a remainder, and you need to take the divisor into account. Okay? The reason for this, when I divided that, what did I say, 730? Yeah. When I divided that, you end up with, did I actually finish it? 2, 4, you get 10 there, 243 with a remainder of 1. If you go through the full process, okay? Back in the first problem. Well, I can write this a couple different ways. I could write this as 243 remainder 1, or I could write it as 243 plus 1 over what? What does that remainder 1 represent? 1/3. That's how we're going to write one like this that doesn't have a nice remainder. Okay? Let's go ahead and look at this one. What's going to go out front? Yep, the x squared plus x minus 1. Underneath, do I have any missing terms here? No. So it's exactly how it is. 6x to the fourth minus x cubed minus x squared plus 9x minus 3. So when I go to this division, the nice thing is actually ones that look harder like this usually take less time. And the reason for this is, what do I multiply x squared by to get 6x to the fourth? 6x squared. So I'm already jumping right to here. So I don't have to fill out every single one because I'm starting with the quadratic. So when I multiply that, that gives me 6x to the fourth. Then what? 6x to the third. Negative 6x squared. Subtract all of that. Careful. Negative x cubed minus 6x cubed. Negative 7x cubed.
And then it would be
5x squared. Negative 1 minus negative 6 will be the same as adding 6, so 5. Bring down the 9x. Now, what's going to go up top? Negative 7x. So that will give me negative 7x cubed. Then what?
And then it would be
Yep.
And then seven.
Plus 7x. And with all that, I'm going to subtract again. What do I get for the quadratic term?
12x.
12x squared. For the linear? 2x. Bring down the negative 3. Then, what goes up top? Plus 12. That gives me 12x squared plus 12x minus 12. When I subtract those,
You get negative 10x.
plus 9. Negative 3 minus. I always, when I'm doing this, I always go this minus this minus this, and I literally talk that out in my head. Negative 3 minus negative 12 minus a negative. Negative 3 plus 12 gives you 9. So if I wanted to write the actual solution to this, I would have the 6x squared minus 7x plus 12. Then what would need to be after that? Plus what?
Negative 10x plus 9 over x squared plus
Over the thing you were dividing by in the first place. That would be the solution to this division problem. And you need to write it that way. You can't just put an R in the number. Questions so far? Okay. That's long division. We also have synthetic division. Okay? Now, synthetic division, honestly, if you use it at a very specific time, it works very easily and very quickly. The thing is, some people try to expand it. It does technically work for larger things. We're going to only use it when your divisors are linear with a leading coefficient of 1. So x minus a number. The reason for this is it works for larger things, but it's very easy to screw up the math going on. It's very easy to screw up the signs, so we don't use it for anything else. We use it for this isolated case. And it works a lot quicker than long division does in this case. Because what do you do for this? Has anybody not seen this before at all? You have. We did it last year.
I don't remember seeing it last year.
Okay. We did synthetic division last year.
We did it was like.
Did you see it?
No, we didn't.
It looks familiar, don't remember how to do it.
I didn't let you guys use the calculator for like 2 days. Then you were mad at me when when you found out that the program existed.
That sounds about right. I remember it seems so
Okay.
horrible.
For this, the idea is you're dividing by x minus k. That k number you're going to put in the top left. Okay, I draw it a little bit differently, but you put a box around that. Then you have your coefficients from your dividend. Then you just always add down. Then you take k times whatever's down here, multiply it goes diagonal. Add down, k times whatever's down here goes up here. Add down, so on and so forth. Okay? The last number down here in the bottom right corner, that's your remainder. Okay? Let's actually look at one. This is one of those, honestly, do 5 or 6 of them, you'll have it solid. So, if I have this problem, and I want to use synthetic division to divide. Now remember, your divisor needs to be in this format of x minus k. What would the k value be in this case? Negative 2. Okay? So I'm going to put that here. I'm going to put a box around that. Now, I'm going to write down all the coefficients that I need. So I have 5, 8, negative 1, and 6. I'm going to leave myself a little bit of room to work, and then write down a line. Now, I'm going to add this 5 to the nothing below it and get 5. That's how you always start, is bring the number down. To get up here, I'm going to take negative 2 times this number, and then diagonally up to here, which means what? Negative 10. And I always add vertically, so 8 plus negative 10 is? Negative 2. Now, negative 2 times the negative 2, what's up here?
4.
Add vertically.
3. Negative 6. 0.
Negative 2 times the 3 gives you negative 6. Add vertically, remainder 0. Okay? Now, we divided a cubic by a linear. X cubed divided by x is going to leave me with what? X squared. So that tells you what this is going to be here. It's going to be 5x squared minus 2x plus 3. That's your solution. You remember it? Okay.
You never really explained it to us like this.
Yes, I did. I went through, I can show you the exact steps, exactly the same.
Did you record it?
Didn't record that one, no.
Oh, I should record it.
Then you could have played it.
Okay, your turn. Go ahead and use synthetic division on the same problem you did earlier.
So you take the opposite.
Essentially, you're taking whatever would make it 0.
No, the top left.
Yeah, top left. You're taking whatever would make this 0.
Okay.
So it's going to be the opposite of whatever that is, because it's the leading coefficient of 1. So that k value will be that -1. Your numbers out front, 1, 0, 0, 0, -1. Okay? What goes down here? Diagonally. Add again. Diagonally. Add. Missed a couple negatives in there, Paul. Negative times negative will give you 1. Remainder 0. So, this, because it was x to the 4th, this will be what? X to the 3rd minus x squared plus x minus 1. Okay? Honestly, practice that a few times on the homework. It's not that bad. Okay. Remainder theorem. Remainder theorem basically just allows you to take that same x minus k format. If you have a divisor that's x minus k, and I just need to know what the remainder is. I don't care what the actual solution is if I divided them. I want to know what the remainder is if I were to divide by this. The remainder, all I have to do is plug in that k value to the original function. It'll give me the remainder every time.
That's awesome.
So if I have a problem like this, and I want to find what the remainder is if I divide by x plus 1. All I do is plug in -1 for the x. So if I do that here, f of -1, well, it's 4 times -1 to the 3rd, plus 10 times -1 squared, minus 3 times -1, minus 8. I don't need to do all the long division. I don't even need to do the synthetic division. I can just plug it in. What do you get for the first term here when you plug in -1?
-4.
-4 for the next?
I'll try it.
Plus 10. Next?
3.
Plus 3. Next? -8. Add them up, you get what? 1. You have 13 and -12, right? So 1. So the remainder, if I did the full division on this, would just be 1. Okay. Now, the advantage of this, and the reason you actually care about it, if you're asked whether something can or cannot be factored, okay? Well, if it has a remainder of what? It can be factored. If it has a remainder of 0. So the idea is, if I can test real quickly and see whether I need to even bother doing a problem or not. Okay, and that's what the factor theorem says. If this is a factor of the polynomial, then f of k will give you 0. So this one, I want to show that x plus 3 is a factor of that polynomial. So what would I do? Plug in -3. When I do that, I'm going to have -3 to the 3rd minus 19 times -3 minus 30. Now what's -3 to the 3rd power? -27. -19 times -3? -57, or positive, I should say, 57. Minus 30 gives you what? 0. So yes, this is a factor of it. So So now if I want to factor it completely, I'm going to use that. Okay, oftentimes you might be able to get a factor of this thing by looking at the graph and then use that to break down the rest of it. So what I'm going to do is I'm going to take, and since this is this format, can I use synthetic?
Yeah.
So let's do it. Top left, negative 3, 1,
0.
0.
oh, 0, negative 19, negative 30.
Drop the 1 down.
Slide down left, right.
Negative 3.
Positive 9.
Negative 10. Whoa, 30. That's 0.
Okay. So what that means is, so far I have x plus 3 times what?
X squared.
Minus 3x. Minus 10.
Okay. So now with this, can I factor that further?
Let's.
No.
No.
Yeah, you can.
No, 3. I mean. Oh yeah, and then you could do the.
Negative 5 and plus 2. Multiply to be negative 10, add up to be negative 3. So will these break down further? No.
No.
You don't have anything. All your x's are reduced down to x to the first power. It means it will not go any further for sure. May stop before that, but most likely not. Okay. Questions on any of this stuff? Okay. This is just a restating of those same theorems. The rest of the time is yours. Make use of it.